I wanted to give a little bit of explanation about what we're going to be doing with the orbit of Mercury. And one of the things is there's going to be a graph right here. And the graph is just a circle with dates around it. It's got 365 dots. The 365 dots correspond to 365 days out of the year. And so what you do is each dot is a day, and it labels some of the days, January 1st, January 15th, February 1st, and so forth. And then you have a table of data. On that table of data, what you're going to have is, your table of data is going to have you measuring the planet and where it is. So, for example, the first one is February 10th, and then 18 degrees east. And so what you do is you take a protractor. So you get a little cheap protractor, and you find February 10, and then to use the protractor, east is going to be to the left, and to the right is going to be west. Okay, so what we're doing is we're looking at up the sky, and we got the sun and we got Mercury either left or right of the sun. And so what we do is the first one's going to be 18 degrees east. East is to the left. So you take the protractor, and the center point of the protractor here, that center point is the 0, because you're measuring angles relative to there. So you put that on February 10, and you line it up right there so that it's right there at February 10, the center point right there, the center of the curvature. And then you make this line right here go to the sun, and then 18 degrees is like right there. So we're going from there to there, and so what you would do is you would then draw a line, and that line would be straight in that direction. Okay, so you draw a line from the date in that direction. Okay. And then what you do is you have another day. You take the protractor here and go to the next day, which is up here in March. Okay, and at that point it's going to be so many degrees to the west. And so you put it over here. Put that right on the date right there. Okay, put it right on the date. Okay, so you put that on the date. This 0 line lines up there, and it's going to be like 24 degrees. So from there to there, okay, and so from that date over to here, go like that. Okay, the next date, it's going to be up here, and it's going to be in that direction, and so you draw a line kind of like that, and the next date is going to be off in this direction, so you draw a line like that, and the next date is going to be over here, and it's going to be kind of in that direction, so you draw a line over that way, and then the next date over here, and then again, what you do is you put your protractor here. And so that way is right, that way is left. If it's up here, that way is right, and then this way is left. Because what you want to do is imagine you're right there looking at the sun. Okay, so you can actually turn the paper around if you wanted to. So if you're over here, you draw a line off in that direction. Down here, draw a line off in that direction. Over here, draw, and so forth. And so you keep doing that, and then over time, you notice that this eventually starts tracing out an oval. Okay, so eventually it's going to trace out this oval. That oval is going to be the orbit of Mercury right there. And so now, once you have that oval, then you can figure out the closest spot to the sun, the farthest spot to the sun. So the closest distance there, that's the perihelion. The farthest is the aphelion. Okay, if you take the entire distance across and divide by 2, that's going to be perihelion plus aphelion over 2. That is the semi-major axis. You remember the semi-major axis, p squared equals a cubed. So you take that, you cube it, and take the square root, and that would tell you the orbital period of Mercury. Okay, you could find the eccentricity. You remember from the previous lab, eccentricity is aphelion minus perihelion divided by aphelion plus perihelion. So that was from a previous lab as well. Okay, and so that's kind of what we're doing in this lab is we're using these measurements of Mercury and elongations of Mercury in order to figure out the elliptical nature of the orbit. When you look up in space, you notice that the planet is either on one side or the other side of the sun. How far it is from the sun is called the elongation. And so we talked about that with the moon as well. The elongation angle is the angle between the sun and the moon. Likewise, the elongation of the planet is the angle between the planet and the sun. And so, same basic concept. And so, by measuring the different elongations from different places in Earth's orbit, we can then trace out the orbit of a planet. This is what Johannes Kepler did, and this is how he figured out that planets actually move in elliptical orbits, not in the circular orbits everybody had thought they were moving up to that point. So that's what this lab is about. And so I wanted to give this quick sort of explanation of how you make that graph right then there.